All right, guys, so this lesson's on slope fields, and basically a slope field is just a graphical representation of a differential equation in a finite set of points. So it basically is just think about little tangent lines. We know that little tangent lines are our slopes, and when I have a whole grid of little tangent lines, that's what's a slope field considered. But those tangent lines don't magically appear. They come from differentiable functions or differential equations. So if you see here, I say that slope field is based on the idea that a differential function and the solutions to differential equations has tangent lines at every point. So in my first drawing, this is a differentiable function. I'm able to take the derivative. This is f of x. So I can just create these tangent lines along this curve. And when I create those tangent lines, if I was to erase this curve, I would just have these lines, these tangent lines not hugging anything. And that's what a slope field looks like. It's going to look something like that. All right, and that's created by just going along the curve and creating tangent lines. Next, if you look at this is a differential equation. So this is, if you know this equation, it's x squared, but this is as dy dx is equal to x squared. And what this is saying is that if I plug in these points, these are tangent lines. If I went ahead and tried to solve this differential equation, okay, I integrated it, x squared, add 1, I get x cubed over 3 plus c, I get a cubic function with some constants, 1/3. So these are general solutions. And I'm saying if I'm drawing these tangent lines along the curve, I'm going to create a slope field. All right, slope fields are also called vector fields or direction fields. They are a tool to graphically obtain the solution to a first order differential equation, meaning I'm not going to go from a second derivative and try to integrate 2 times using a slope field. All right, so let's just kind of go through exactly what they're asking. Here, this is a typical part 1 question, and again, this AP exam will not have any part 1s. It will only be a free response exam. However, this could be considered part A of a free response, where they said which choice represents this, or they might say create the slope field of a derivative, a differential equation that says dy dx equals cosine of x. So literally, all you're doing is creating a table of values and matching which one this could go with. So I'm going to go ahead, and my table of values no longer is going to be x, y separated. It's going to be the point and my derivative on the other side. So here, if you look at this, I'm going to say, all right, if I look at this derivative, what I notice is that only x matters here. All right, so I'm looking at it could be the point 0, 0, or 0, 1, but regardless, when x is 0, what does this slope equal? So I look at this and I go, okay, when x is 0, that means the slope is cosine of 0. And we know cosine of 0, that slope value is 1. So I go, okay, so at 0, so if I was to just try to graph on my own, not matching, at 0, 0, I know that my slope would have to look something like this. It's a positive slope. I would be imagining drawing up 1 over 1. If I said 0, 1, well, that's that point. Again, I'd be plugging this in, and I still get 1. So along x being 0, for all those values, that's what my tangent lines would be. Now it's very careful, you don't want to make them connect to anything. These are distinct values. So the next I'm going to see is what happens. Well, I don't know when cosine of 1, but I do know cosine of pi over 2. So let's see when x is equal to pi over 2. And roughly pi over 2 is 3.14 divided by 2. So that's roughly 1.57. Okay, so I'm looking here and I'm going, okay, when cosine is pi over 2, well, we know that value is 0. So this might be 1, and this here might be 2, and this is 3, and so on. And at 1.5, right around here, I know that my slope is going to be 0, which means that it's going to be a horizontal line drawn at this value of pi over 2. And then last but not least, I'll finish off with cosine of pi. So when x is pi, well, we know cosine of pi is equal to -1. So we know that pi is roughly 3.14, correct? So here at 3.14, just over, I'm going to be making a -1 slope. So it looks like something like this, looks something like this, looks something like this. So if you had a matching scenario, you would be looking for a graph that along the y-axis, you have a positive slope. So I see A is a contender because I see that this slope of 1. I see that B is not a contender because that slope is horizontal, saying that it's a 0. Here, again, it's horizontal, so C's out. And then here, D is a possibility because it's 1. And E's out because it's negative there. So I've been able to take those out just because I know that when x is 0, my slope is 1. But then I'm looking at further. When it's about 1.5, I'm seeing a horizontal. So here's 1.5, and I kind of see horizontal here. So I'm thinking this is a contender. And here's between 1 and 2. I also see a horizontal. So that's not enough to distinguish which choice it is. So I go to cosine pi when x is pi, which is roughly 3.14, which is just over here, just after that 3, and it's a -1. Well, there's a negative. There's a negative. Okay, so I like what I see there. And here at 3, I see that it's a positive. So now this one came out, and this is my answer. All right, that is what we did, was just created a slope field for the differential equation cosine of x. All right, so this packet you have, I want you to try number 2 for homework. I want you to try number 3. And just remember that when they say the slope field for the differential equation, and they give you the different will be vertical. Well, we know we have vertical slopes when your value is undefined, when your denominator equals 0. So think about that a little bit, and we're going to go over that together. 4, I don't need you to do. And then the last thing I want to talk to you about is 5. This is an example of a part 1. I thought this was a little bit on the difficult side just because of what the derivative was, but again, what they're going to ask you in part 1 will say to sketch the slope field for the differential equation. So here's my differential equation. Literally, you have 12 points that you have to make a table of values for. So this point 0, 0, this point being 0, 1, this point being 0, -1, 1, 0, so on. So it took a little time, so I just am showing you, and I will include that in a photo for you. This is the table of values. Here's 0, 0. If I plugged in 0, 0 to the derivative, that the differential equation that they gave me, when x is 0 and y is 0, I get the denominator to be undefined. So you can do 2 things here. You can draw a vertical line, but what I'm seeing is that it's not necessary, so I wouldn't. And as I was going through some of these AP questions, I noticed that they usually do not ask you to draw a vertical line. They would ask you to just create the slopes at these points. So moving on, any x value being 0 would make this denominator undefined. So you leave it alone, or you can go ahead and do that vertical tangent line. All right, when I move on to 1, 0, that's this point right here. If I plugged in 1 for x and 0 for y, I got 2 as my slope. So what you want to do is make sure that you create a slope that's positive and that's not so, that's a little bit steep. Like you want to actually think about creating another point up 2 over 1. And if you were to connect that line, what does that slope look like? And so that's why it's pretty steep there. If I continued and I plugged in 1, 1, again, you plugging into the work, you get 3.08. Well, you know comparatively that's steeper. So above it, 1, 1, it's going to be a steeper slope, and so on. So this is how you would continue. You would just make a table of values for every point that they give you. Usually I see 6, but you can go all the way up to 12 points. Nothing more. If you're looking at this, yes, I did the exact values. You can estimate, and sometimes you'll see a pattern. So always look for that. All right, so that's part number 5, part A. Part B is in the problem is asking you to write the equation of a line tangent to the graph. So again, we need to know a point, which they gave me here, and they gave me the slope that you have to evaluate. So this is something you can already do, and part C, I believe you can do as well. So that's going to be part of your homework too. So your homework is just to try number 2 on this, number 3, and finish number 5. All right, and I will be having a Google Meet on Friday to answer any questions.